All right, good morning. Thank you very much for attending the first session of the second day. Um, I wanted to spend the next 25 minutes or so to talk about cyber resilience. So my name is Philip Verlooy. I'm the field CTO for Rubrik X. We focus on data security. Um, Broadly speaking, our sort of big hairy goal, if you will, is to secure the world's data. And our approach here is sort of changing based on what we've sort of seen in the market in the last couple of years. Is that there's of course a lot of ransomware and ransomware activity that's in the public news, but what we've recently seen is there's also a big data exfiltration component. So now what we tend to focus on is how can we implement both preventative measures and also recovery measures at the same time using the same platform, which is, in our view, what will lead to cyber resilience. So this concept of cyber resilience that we think about from a Rubrik perspective is really this idea of, let's assume the worst happens, let's assume breach, but also let's assume your environment is not available. How do you bounce back, and how do you bounce back quickly? And maybe even theoretically, how do you bounce back in a better state than before? So the reason why we're sort of shifting to this mindset instead of focusing purely on prevention, if you sort of look at the amount of money that we're spending on prevention, it crossed the $200 billion mark last year, according to Gartner. So that's spent on services and preventative security measures trying to keep your environment safe. And that's probably a good thing. If we weren't spending $200 billion, there would be a lot more cyber incidents, but it's also not really working if you look at the amount of incidents that we are still seeing on a day-to-day basis, let's say. So the idea is that we assume that people will get emails. Emails will have some, weird links in them. Sometimes people will still click on stuff they're not supposed to click on at some point. That's sort of becoming unavoidable. And also, if you use any software components, you will have bugs at some point, right? So every piece of software in the world has bugs. Some of these bugs are security vulnerabilities, and some of these vulnerabilities can be exploited. Just think about how many updates you need to run on a weekly basis on the apps on your phone, for example. And then if you think about software in a broader context, especially in a distributed context, when we incorporate things like cloud and multi-cloud, all of these systems, they tend to break constantly, actually, as well. So if you're relying on a third-party payment provider, for example, to keep your services up and running, at some point those systems won't be available and won't be secure, and you need a way to deal with that, to keep up and running. Usually when we thought about cybersecurity, we sort of had this mindset of it will happen at some point to us. So it wasn't a matter of if it will happen, it was a matter of when it will happen. But what we're seeing today, especially with people who tend to pay ransom initially, is that it's not a matter of when it will happen, it's a matter of how many times you will be a potential victim to this. And that's why resilience is becoming such a big component here. So switching to this mindset of resiliency, aka assume breach, will hopefully free up some mental roadblocks and help you shift from focusing purely on keeping people out to building a solution where you can bounce back and bounce back quickly. Why are we focusing on this? And specifically when it comes to hybrid cloud, multi-cloud, and SaaS applications. So these are some figures from the latest IBM X-Force Threat Intelligence Index of 2024. What they've picked up on is that there's a 71% year-on-year increase in cyber attacks using weak, leaked, or stolen passwords. Especially for the public cloud, that's the biggest initial attack factor, is people logging into your environment. It's become very, very easy to find credentials. People are happily pasting things like tokens on GitHub and Pastebin and so on. Or they can be acquired quite cheaply out of an info stealer campaign, for example. So logging in with valid credentials has become really easy. And especially because the login portal now lives on the public internet, people are sort of abusing that concept more and more. Of those attacks looked at in 2023, which is what the report covers, 32% include a component of data theft or data leakage. So we see that this is typically what people are after. Either they have some sort of cause and they want to disrupt the operations of your organization, or they want to encrypt your data, hold you for ransom, or they want to exfiltrate your data and hold you for ransom so they won't leak it on the dark web, for example. Thinking about these attackers, they've also shifted their approach a little bit, and they will follow this path of least resistance typically, right? Maybe unless if it's a nation state, but typically malicious actors who are after your data have figured out that it's much more easy to use valid credentials and to log into your systems instead of trying to circumvent any perimeter security control that you might have. Maybe you have some sort of esoteric IoT device that they need to break, or you have a very, very powerful perimeter firewall and you're doing micro firewalling in your data center, et cetera, et cetera. Instead of trying to break those specific systems, maybe waiting for a 0-day, etc., why not use valid credentials they have access to, log into your cloud environment? Once they're in, look around, laterally move through the system, get a privileged account, and get to your data that way. So more and more we're seeing that's the actual path that people are taking. Additionally, why this is becoming so important is that if you look at the growth of data, the majority of new data is being created either in a public cloud or in SaaS applications. Thinking about where, let's say, most of your innovation is happening and most of the newer applications appear, they will typically appear in either the public cloud or you're consuming a SaaS service like Microsoft 365, for example. So that is where the majority of user data and also application data tends to end up these days. And people who are after your data, of course, they know this as well. So they are targeting those environments more than they're targeting on-prem environments. It's going to take a while to get to this point where there's more data in the public cloud and more data in SaaS than on-prem, but slowly we're sort of getting to that point. And especially new data, which tends to include a lot of PII information, lives in those cloud environments. Switching to the cloud then, there's also new blind spots, I would say, for existing security controls that you have on-prem and you're trying to lift and shift into a cloud environment, things like virtual firewalls and so on. They do not tend to understand natively these new services that you're incorporating. So from a data perspective, for example, think about the data types that we see in the cloud. 70% of those data types are object-based. They're not block, they're not file. So they require a different approach in trying to understand what is in that object data asset, who has access to it, how is that flowing through your on-prem/hybrid cloud environment, and how are you consuming those services. And then of that new data in the cloud, 25% contains regulatory related data, either PII information or maybe from a financial standpoint, PCI type data. So that data is much more interesting from a malicious actor perspective to go after than just any regular data set you would have anywhere else. So there's a bunch of, as we call it, cloudy prospects. Like if you think about what the weather will look like, next week, next month, next year. So far, there's not gonna. We're not sort of seeing like a lot of positive news, let's say. And why is that? If you think about the monetary benefit potentially that hackers can gain or malicious actors can gain from ransoming you, it's still quite high. So we see there's a ransomware event every 40 seconds globally, and every 10 seconds it's successful. So every 10 seconds there's either a data exfiltration or a data encryption event, and somebody has yet another, let's say, incentive to try to hold you for ransom. Because you're adopting these new systems like hybrid cloud, multi-cloud SaaS, the attack surface that you need to protect is also growing as well. So you need to be an expert now in Azure, AWS, Google Cloud, but also these SaaS services in how you implement the available security controls that those providers have to safeguard your environment. Especially in Europe, now with DORA and NIS2 regulation and the potential fines that are associated with that, it's not a bad thing. It's actually elevating this conversation a lot in, let's say, the company management. At least that's what we are seeing, because there's now company management liability included in those regulatory frameworks. So if somebody is going to hold the directors of your company liable for a data breach or a data exfiltration or the failure to report on those activities, that will be a forcing factor in having people adopt more security around that in general. Misconfigurations is also still a big one. So misconfigurations that we make ourselves as end users in the cloud can happen. Of course, you can, inadvertently create an S3 bucket, for example, and share it publicly on the open internet. People will have access to it. But we're also seeing the cloud providers themselves struggle with some of these misconfigurations. A recent example of 2 weeks ago was Google deleting a production environment of a large customer in the US, including their DR site and including their Google Cloud backups. So without any third-party backup, their entire environment would have been blown away and they would have been out of business, essentially. So you sort of need to build this into your cyber resiliency thinking as well. More and more insiders, so if you have people leaving your company, they tend to take some of your PII data with them to your competitor. It's a reality of what's happening, but also what we see is malicious actors actively targeting IT staff in your organization to try and help them get into your environment more easily. And then finally, because of geopolitical tensions these days, especially in Eastern Europe, we're also seeing more and more APT activity as well, especially from the Chinese and Russian side. So Microsoft was famously breached a while ago by, we all assume, the Chinese, but that happened in 2008 to Google as well. So essentially nobody is safe. Like today it's Microsoft's turn. I'm sure AWS is going to struggle with this next. But the whole idea here is that they are shifting their tactics to the cloud as well. So there was a joint statement from the NSA and the Five Eyes organizations across Europe and Australia saying, we have seen Russian hackers specifically leaving on-premises environments and focusing purely on the cloud. So what do we do about this, essentially? So from a Rubrik perspective, we've divided our solution, our platform, it's an integrated platform, into separate approaches. So there's like a pre-breach approach and a post-breach approach, if I can call it that. So with the pre-breach approach, what we're trying to do is we assume there will be an incident. So somebody will be able to log into your environment at some point using stolen credentials or a phishing campaign, something like that. How do we minimize the potential blast radius of getting access to your environment so no significant amount of data gets leaked or no sensitive data gets exfiltrated, so there's minimal impact to your organization? So the way that we do that is we implement data hygiene. So we understand where sensitive data lives across all of your on-prem, cloud, multi-cloud SaaS environments. And then the idea is if you're not using that sensitive data because maybe it was a test and dev copy that you gave out to a developer at some point, why not get rid of that data? So you don't have to pay the cloud provider to host it, but it also can't be exfiltrated if it doesn't exist anymore. So that's sort of step one always. And then step two is you want to implement this concept of least privilege also in your cloud environment. So you have a lot of accounts, a lot of roles in your cloud, but people are struggling to understand how those identities map to data access on the back end. So by visualizing that, we will help you implement only the permissions that are actually required to perform day-to-day operations and take away anything else. So an example could be, let's say you implement a third-party monitoring tool for your public cloud. You buy Datadog, for example, or something that comes with a service account. What if we map out what that service account has access to from a sensitive data perspective? So you understand, well, why does it need write permission on some engineering database that we have where all of our company information is stored, all of our proprietary information is stored. So by showing you that, you can dial it back and implement only what makes sense for your environment. Then the third one I think is super important. So you have the capability to implement security controls in Google Cloud, in AWS, in Azure, in SaaS environments, but you don't have the capability to say, I'm organization X and I want to implement a baseline of security control across the entire multi-cloud. So the idea is you can't really implement a policy that says, across the multi-cloud, people are not allowed to expose sensitive information publicly. By assessing the data posture with Rubrik, you can actually implement that. So we will take this policy, this high-level policy, and translate it to whatever cloud provider you want to monitor and validate if that setting has been made yes or no. With data access governance, we again sort of show you in semi-real time who is consuming your data assets from an identity perspective. So not only who has access, but who is creating more data and who is reading data from your assets sort of on a continuous basis. And then the final piece is we want to implement anomaly detection. So can we understand how your data is supposed to be used on a day-to-day basis? Think about, I'm an engineering company, and I have a bunch of data records in a database. And on an average day, the engineering team pulls, I don't know, between 1,500 and 2,000 records out of the database. What if the next day in the morning somebody logs in from engineering and they pull 1 million records out of the backend database? That will be an anomaly, that will be an outlier. That's not how you normally interact with your data assets. So things like that we will flag. And again, the idea is if we flag it quickly enough, it will still be an incident, but it won't lead to a breach. So that's the concept. Everything behind the orange dotted line is this concept of, well, if the worst has happened, we are down, our data has been encrypted, for example, how do we understand what was impacted and how do we restore all of that data and application as quickly as possible without potentially reinfecting our environment, so we can confidently restart our organization again, essentially. So what I wanted to do next in the next 10 minutes or so is to show you a quick demo of the pre-breach capabilities. I'm still at the booth afterwards, so if you want to see the post-breach capabilities, happy to show you those as well. But I just wanted to focus on the pre-breach just for a second. So this is that pre-breach tool set. We call it Rubrik Data Security Posture Management. So the idea is we want to evaluate your data security posture and help you minimize your data attack surface. So how can we bolster the security as much as possible from a preventative approach first? So how do we do that? First thing that happens is you basically onboard your cloud accounts. So you add in whatever cloud provider that you're using. What the system does is it only leverages cloud native APIs. So there's no agents, there's no proxies, there's essentially nothing to install. We basically just talk to your APIs, we look at server logs, we integrate with things like CloudTrail and so on to understand what is going on in your environment. First thing that will surface is what is all of the data that you have across these environments. So we'll build a full inventory. In this case, we have 734 data assets across all of these cloud environments that I added. What does that look like in a little bit more detail? So if I click into the inventory, you can see all of the data assets that we have in these environments. Actually, let me do it like this. So this is all of the data that I have across cloud. So this can be things like SharePoint, OneDrive, S3 buckets, RDS databases, Google Cloud Storage, etc., etc. We'll automatically classify that data as well according to your preference. We have a large set of built-in data classifiers, general things like credit card numbers, passport, IDs, etc., but you can give us your own as well. So by doing that, we understand how secure is the asset itself, how sensitive is the information inside of the asset, and combining those things, those two things, how big is the risk to your environment then? Meaning, if this asset isn't properly secured, and there's a lot of, in this case, restricted information in it, that means it's a critical risk to your environment. What does that look like then, the risk? So we'll perform a risk assessment, in this case on the S3 bucket. So we'll say things like, oh, there's sensitive data in there, but also you don't have encryption set, you don't have access logging set. So you, in essence, you don't even know if somebody is misusing this bucket and exfiltrating data because there's nothing in the logs, there's not going to be anything in the logs about it. That's the asset itself, the infrastructure component, let's say, insecure. But what about the data inside of that asset? So here with the Data Explorer, we can drop inside any asset. And then on the right-hand side, you can sort of immediately see where most of that sensitive information is coming from. So in this case, for example, we see there's a bunch of directories with some client data, for example. But there's also this STEM directory with a lot of business and financial data. So if you open that up, we can see there's somebody made a dump of a database, which is fine, but this is where the database originates from. So we can see it's coming out of an RDS database. It's publicly exposed on the internet. So the bucket policy is publicly exposed. This is your data at risk. And this is the additional context we have wrapped around it. So our context engine looks at what is the data asset, what does that file mean, what is in that file, and we've determined that this is a dump of a SQL database, and inside of that SQL database you have employee and customer records. How do we know that? We can actually see, we can pull apart that structured data set, so we can do this for structured, semi-structured, and unstructured data. And here, for example, we can pinpoint in let's say a random column in the production table, there's user IDs, there's phone numbers, etc. So that's what our classification engine has determined. You can also take a sample. So if you want to validate from a production side that this actually contains the data we're telling you it contains, you take a quick sample, we'll give you a random data outside of that column so you can verify this is what's in there. You can't copy paste this stuff. You can take a screenshot, of course, but this is sort of how we provide this. So this is purely the inventory part. This is what you have, and this is how exposed you are from a sensitive data perspective. The second piece is really how secure are you from a data security perspective across these cloud environments. So we can implement a bunch of security policies. So we have some examples here, like looking for redundant data, misplaced data. So misplaced data is things like, I'm an EU country, I need to adhere to the GDPR regulation, I have PII information from European citizens, I've put it in my Western European data center, but somebody created a replication policy to Singapore, so now I have EU PII data in the Singapore data center of Azure, for example. If you say that's not allowed, we can put that in a misplaced data policy, and then, for example, here say, there's EU email addresses here. If you open up the asset, we'll show you where this data is, and in this case, it's in North Virginia, so not allowed. So the idea is you have to pull this back into a GDPR validated location. If we go back to the earlier example of that has 3 buckets, so there was sensitive data exposed. So from a security perspective, we can see the same thing, but the additional context you now get is how do you fix that? So the system will give you a remediation hint. In this case, this is a new bucket policy that we've created on the fly. If you implement this bucket policy, this public exposure will go away. We'll also spit out the AWS CLI command to make it easier. I'm not suggesting you should just copy paste and do this, but the way that we would operate this is we will take this remediation hint and we will populate a ticket, a Jira ticket, a ServiceNow ticket, whatever ITSM tool you have. We'll push that information in there, and then the data owner or whoever is responsible for securing that data will pick up that ticket and implement that remediation. That's really the goal. So typically it's not done from our interface. So you implement the policies that make sense for your environment. The system comes with a set of built-in policies. You can create your own as well. And we try to link those policies to regulatory frameworks. So for example, if you say, show me only the GDPR-related policies, we can look at things like, oh, you have to implement encryption at rest to protect your data, for example, in an EU data center. In this case, you have not done that for 5 of these data assets. So that would be the overview. The final quick piece, I want to, actually 2 more pieces I want to quickly point out, since we have a couple more minutes. So I spoke about how do you understand identities and how do you expose your sensitive data on the back end. So what we do is we integrate with your identity environment, your IAM environment, your IDP providers, and we'll map out how users have access to data. How do we do that? So for example, here I have a Matthew Johnson. We've pulled this information out of AWS EIM in this case, so we can see it's a senior QA engineer. These are the groups assigned to Andrew Johnson, and these are the cloud roles assigned to Andrew Johnson. If we take these assigned permissions, what we'll show you are the effective permissions. So we'll add all of these up, and then we'll say, effectively, you're exposing all of this potentially sensitive information to this senior QA engineer. That's probably not what you were expecting. We also visually want to map that out. So here we have Matthew Johnson. This person has read and write permissions across these 3 accounts, and these 3 accounts give access to this data on the backend. So now you can visually understand what you're sort of exposing. You give this to your IDP engineer, and they'll turn the dial back to what is actually needed. So where else do we leverage that information? If you look at data threat alerts, that's sort of the final piece of the platform. I'll show you one quick example. So here we use AI and machine learning to understand expected behavior in your environment. And for example, what we can see are things like somebody logged into your system and they downloaded a bunch of sensitive information to their laptop. And that is not how your engineers or your employees normally deal with data in your environment. So how have we mapped this out? The activity is coming from an IP in the US. This is the application that they were using through Chrome, essentially. This is the data, sensitive data that was exposed, and this is the actual data that they downloaded. So by integrating with your server event logs, we can actually see exactly which data was exfiltrated. So think about having to build a report for a regulatory body after a breach and having to tell them, this was the sensitive information that was exfiltrated, this was the impact in my environment. It's very hard to get that information. Here we've centralized this, and you can export it and just show it to your regulatory body. The other quick view we have is the event view. So here you can see essentially, even from an API perspective, how are they interfacing with your data. So you can see here they used a Chrome browser, and they did a GET request on an S3 object, which was essentially successful, and that's how they downloaded all of your data to their laptop. All right. So that was a super quick whirlwind tour of the solution. As mentioned, we are on the exclusive network booth just across the aisle here. So if you want to also see the resilience piece and the recovery piece, or ask a bunch of questions, I'm going to be there until noon today. So happy to do that. Again, thanks for attending the first session of the day. I hope it was useful, and enjoy the rest of the show.